What's going on, guys? You know, there's been one thing that's been bothering me about this KTM ever since I bought it, and today we're gonna fix it. The headlight that comes with the KTM 1090 Adventure comes with a yellow incandescent bulb, or two yellow incandescent bulbs, surrounded by a series of white LEDs. The two different colors kind of bug me, and I know I'm being picky here, but I started wondering, could I upgrade my incandescent bulbs to LED bulbs and make the colors match? And are LEDs the right choice for me? That thought process then sent me into a tailspin of other thoughts, like, why are LEDs becoming so popular? And are they legal on motorcycles? What are the downsides of LEDs? And how bright can a headlight legally be? And most importantly, can LEDs potentially save me money by eliminating the need for auxiliary lights? We're going to cover all these topics and more in this video. So here's what I've learned about LEDs and why they're becoming so popular. LEDs, or light-emitting diodes, are just that, a diode that emits light. These semiconductor light sources first found their way into the average American's home in the early 1960s in the form of an ultraviolet LED in the front of the television remote control.
An amazing new wireless wizard electronic remote control.
So as with anything, there are upsides and downsides to using LED replacement bulbs in your motorcycle's headlight. Let's talk about the upsides first. LEDs consume less power, are more durable, have longer operational lives, and like their incandescent grandparents, come in a variety of different colors. Incandescent bulbs last about 1,000 hours before they burn out, whereas LEDs last between 15,000 and 30,000 hours before they burn out. If you keep your motorcycle long enough, the longevity of a quality LED will more than make up for its initial upfront cost. This is true over incandescent, HID, and halogen bulbs. In general, LEDs are capable of providing a more whiter, natural-looking light when compared to the yellow tones of traditional incandescent bulbs. Now, to the credit of incandescent bulbs, through the use of special filaments, colored glass, and stable gases inside the bulbs, they have started to become more capable of producing that white, natural-looking light. However, when you start paying for the additional cost of those special incandescent bulbs, you're then playing in entry-level LED territory anyway, and those incandescent bulbs are simply not capable of producing the same amount of light, meaning they're just not as bright. On the subject of brightness, LEDs are also capable of emitting more light with less power than incandescent bulbs. This is, in part, why LEDs are becoming the standard in the automotive industry. So if LEDs can produce more light with less power, doesn't that mean that LEDs are better? Well, not necessarily. Although LED lights are brighter, there's more to the story. As a user, what you're really looking for out of an LED is a bulb that satisfies your need to illuminate your path while throwing the exact same beam pattern as the incandescent bulbs that came with your motorcycle's headlight. A properly engineered aftermarket bulb should throw the exact same beam pattern as the one that came in your motorcycle. If your reflector is designed for an incandescent bulb, this can be a little challenging for an LED to achieve. The shape of the LED, whether it's square or round, whether the manufacturer is using a series of LEDs in an array or just a single LED chip, whether there's a bubble on the LED itself that helps focus the light, and finally the exact distance from the base of the bulb to the point at which the LED is mounted on the chip. Those all should mimic your factory bulb as closely as possible. If any of these design factors differ from your factory bulb in any way, you may have problems. Additionally, your factory reflector is designed to focus a specific amount of light coming from a precise point within the headlight housing. Any variance can cause significant problems. Problems like poor throw resulting in not enough concentration of light in your path, or too much throw or too much spill of light, which is likely to blind oncoming traffic. These are just some reasons why poorly designed aftermarket bulbs might not be your best option. So what are the downsides of LEDs? Well, it's a hot topic, literally. You see, both LEDs and incandescent bulbs produce heat. However, incandescent bulbs produce heat in the front of the bulb, and that heat is projected away from the bulb into the open space between the reflector and the lens where it dissipates. LEDs do not project the same proportion of heat forward into the open space between the reflector and the lens, but instead retain that heat within their circuitry. LEDs themselves are mounted on a circuit board, and that circuit board is generally surrounded by a large metal heat sink. That heat sink is typically backed by a fan or series of fins that help dissipate that heat within the circuitry. So the question is the heat that an LED produces a problem? Well, it depends on a number of factors. It depends on how well your specific headlight housing works with the LED that you're installing, and more importantly, how well that LED that you're installing dissipates the heat that's generated. If your bike lacks sufficient airflow in the bulb housing, or the bulb is not designed well enough to dissipate the heat that's produced, your headlight housing will heat up and could potentially be damaged. It's worth mentioning here that there are a lot of cheap aftermarket LED headlight bulb alternatives. Generally, those cheap alternatives are not backed by the same level of research and development as a quality LED. Because of their poor design, these cheap alternatives tend to burn out well before their operational lifespan is up, meaning the LED itself is still okay, but the circuitry and the heatsink surrounding that LED may have heated up too hot and caused itself to fail somehow. And this is another case in which it might not be worth it to buy a cheap alternative. So don't despair. That doesn't mean that LEDs are bad. What it means is you should purchase a well-designed LED bulb from a reputable manufacturer that knows how to test and design something that won't cause a catastrophic meltdown.
Plus, you have the high beams on.
I can't quite read the sign.
So to recap on this topic, LEDs are capable of producing more light with less power, are more durable, have longer operational lives, and generally produce a more natural white-looking light than incandescent bulbs. If an LED is properly designed, it'll work with your headlight housing to produce a high-quality beam pattern, but if not properly designed, can create some serious problems. Additionally, poorly designed LEDs won't be capable of dissipating the excessive heat that's produced, which may cause them to burn out prematurely or even damage your motorcycle. On the other hand, well-designed LEDs will be engineered to work with your specific motorcycle and should outlast many other components on your bike.
Hey, that's pretty good.
So the question remains, are LEDs legal on motorcycles? And how bright can headlights legally be anyway? In the United States, laws regarding color, brightness or output, and height requirements from the ground, along with a number of other factors, all vary from state to state. However, there are some very general federal regulations and standards which manufacturers must adhere to. We'll talk about those here. Depending on your headlight's design, low beams should range from 15,000 to 20,000 candela per lamp, whereas high beams should range between 18,000 and 75,000 candela. But what is candela, and how does that compare to the lumens which are quoted on most manufacturers' packaging and advertisements? Candela refers to the perceived visible intensity of a light at a given point. Think about an emergency vehicle's flashing lights. They don't always want the brightest light with the most output or throw, but instead what they're looking for is a light with good intensity that is highly visible to those around them. This perceived visible intensity at a given point is measured in candela. Lumens, however, refer to the total amount of visible light produced that doesn't take into account beam pattern, unlike candela, but focuses instead on the specific point at which the light is emitted and how much total output of light is produced. Generally, if your reflector properly focuses the light, then the more light produced, the better you'll be able to see objects in your path. Automotive reflectors are designed to throw a percentage of light and flood that surrounding area with low intensity light so you can see things alongside the road. Additionally, automotive reflectors have a cutoff line, which is designed to prevent you from blinding oncoming traffic while maintaining a usable beam of light. By emitting more light, you can actually overwhelm your reflector's ability to focus that light and maintain its cutoff line. Any light emitted above the cutoff line will negatively impact other drivers. The two terms candela and lumens meet in the middle, literally in the space between you, the person emitting the light, and someone else, the person perceiving your light. Federal regulations are based on candela, whereas you're probably more concerned with your ability to see things, or brightness, i.e. lumens. The standard incandescent headlight produces around 1300 lumens, and it's rare to see an automotive LED headlight that outputs more than 1600 lumens under normal conditions. Now, a note about LED output. Generally, lumens quoted by manufacturers are theoretical maximums based on calculations, not actual output based on practical real-world tests. Now, it's worth mentioning that LED lights are brightest at cool temperatures, which means that LEDs will be their brightest when initially turned on, and will gradually lose brightness and plateau somewhere between 60 and 80% of initial brightness. For this reason, it's important to test LED bulbs and their functionality at full operating temperature. Now, Title 49 in the Code of Federal Regulations, Part 571 of the Federal Motor Vehicle Safety Standards, Standard Number 108, focuses specifically on lamps and reflective devices. Standard 108, as we'll refer to it, or the standard, defines a headlamp, as they're referred to in the standard, as comprising of an integral and indivisible optical assembly, including a lens, reflector, and light source. According to a 2013 letter from the National Highway Traffic Safety Administration, or NHTSA, they stated that we would consider LED headlamps as meeting the above definition of an integral beam headlamp, provided that specific design requirements were met, such as a failure of a single LED on an array should cause the entire unit to stop functioning. The NHTSA goes on to note that when motorcycle headlights are vertically oriented, they are held to the same standard as four-wheeled vehicles' headlights. However, they are required to have only one half of a four-wheeled vehicle's configuration, meaning one high beam and one low beam, and are tested as one half of a four-wheeled vehicle setup. According to the same letter, LED headlights within a single motorcycle headlight housing are considered to be meeting the standard. On the other hand, if the motorcycle manufacturer chooses to design their headlamps in two horizontally oriented separate housings, which is common in many motorcycles, and they'd like to integrate LEDs as the main bulbs within those housings, those headlights would be tested in a from-the-ground-up fashion, meaning they must pass a series of tests and motorcycle-specific requirements before this design would be considered to be meeting the federal standard with LED bulbs. Because this design is unique to motorcycles, and LEDs have been determined to be legal for single housing, single lens configurations such as those found on four-wheeled vehicles, but not necessarily for the separate housing setups found on motorcycles. If the manufacturer wanted to include LED headlight bulbs in the horizontally oriented two housing headlight configuration found on motorcycles, they would have some mountains to climb with testing and meeting the design requirements under US federal standard. This could translate to a lot of R&D and ultimately money. This means that LEDs in this configuration are not necessarily illegal. For example, if you have this style of headlight and you install LED bulbs, you've got your feet firmly planted in a gray area. It's also worth noting that if someone's going to the trouble of investigating the legality of your LED bulbs in your horizontally oriented two housing motorcycle headlight, you've probably got bigger problems on your hands than those sweet, sweet LEDs you just installed. On a side note, take a notice of the BMW GS's headlight. It dances right on that line between having multiple headlights and a single headlight because it has multiple reflectors and even a projector or two behind a single lens within a single large housing.
Sounds expensive.
BMW GSs have moved over to using LEDs as standard. In that same 2013 letter, the National Highway Traffic Safety Administration goes on to say that we do not determine compliance of a vehicle or item of motor vehicle equipment outside the context of actual enforcement proceedings. Instead, manufacturers are required to self-certify that their products conform to all applicable safety standards that are in effect at the date of manufacture. So all of that to say, that I don't know about you, but if it's good enough for the National Highway Traffic Safety Administration, it's good enough for me. We, the consumer, are left relying on the manufacturer to properly test their products. We rely on them to ensure that their bulb design is engineered to work correctly with our factory reflectors on our motorcycles, and that they're meeting both federal and state regulations and standards, while satisfying us, the consumer, by providing a quality product that meets our expectations. So let's recap on the topic of LED headlights and legality on motorcycles. Laws about color, height from the ground, or even restrictive brightness standards vary from state to state. Federally, low beams should range between 15,000 and 20,000 candela, whereas high beams should range between 18,000 and 75,000 candela depending on your headlight design. Federal regulation and standards are written in Candela, or the ability for that light to be perceived, where you're probably more interested in usability and brightness, or beam pattern and lumens. We've also learned that manufacturers often quote LED output as theoretical maximums not based on practical tests. LEDs have essentially been grandfathered in when in use in a single housing configuration, as is common in the vertically oriented headlights like on the KTM and the Kawasaki. However, there is still a gray area when installing LEDs on two separate horizontally oriented motorcycle headlight housings. Alright, so let's move on. That brings us to our final topic. Can LEDs save me money by eliminating the need for auxiliary lights? To answer this question and to help you decide, I've come up with 4 simple comparison tests where we'll compare LEDs to my factory incandescent bulbs. First, we'll analyze the beam pattern on my garage door. Second, we'll perform an onboard drive test where we compare the stock lights to the LED lights from the rider's perspective. Third, we'll take a look at the oncoming driver's perspective of the two bulbs. Finally, we'll analyze the illumination distance by performing a series of real-world fixed distance tests where we light up objects at measured distances and see how visible those objects are. Before we can do any of that, we need to get these LEDs installed on the bike, so let's go.
Fans kicking on.
So that's the beam pattern at 16 feet right now. Like I said, I'm a little left of center. This is before, And again, camera settings will be fixed for these before and after tests.
So that's what the beam looks like with at 16 feet away with the original factory bulb. We're going to do a horizontal comparison here where we have the original on top and the aftermarket on the bottom, and we'll just compare.
So here we go. Now we're going to get out and go for a quick ride. This is what the low beam looks like. With somebody behind me, you could back off a little bit so there's not so much pollution. She is behind me, but she's going to be a little ways behind me. And this is obviously there's no street lamps or anything, so it's illuminated only by my light. So this is what the low beam looks like, and then maybe when we see like a speed sign or some kind of a marker, maybe a speed sign, we'll switch to high beam for a bit. This is the beam pattern for the low beam, you can see. Now this is a 20-mile-an-hour corner, so maybe we'll use this 20-mile-an-hour corner as a marker to go high beam for a minute. So high beam right here in the 20-mile-an-hour sort of S-curve. Now it looks better than it is because it's downhill. Skunk. Here comes a car, so I'm going to go low beam here, so I'm not blinding. You can see the cutoff line is really pronounced when you do that. Alright, so there's a good chunk of low beam right there. In this corner, I'm going to turn on the high beams just before it, and then I'll have to remember what I did. There we go, there's the high beams, because it's just not that safe riding this road at nighttime in the dark without your high beam on. I've already seen animals tonight. Alright, so this is a fixed distance illumination test. Brittany's at 115 feet up there. This is the factory or original headlight. Go ahead and walk across the street. She's got a little bit of reflective material, but you can see, walk that way, then turn around. Oh wait, low beam, turn around, do two, go back and forth. So we should be able to see her at 115 feet. I mean, I can see her in real life, but she has some reflective and mostly black on, so go ahead and do it again, BK. Good. Now, walk down to 350 and we'll do high beam test. Alright, so this is the high beam test, 350 feet away. I'm going to point right down towards her. Same exact spot next to the guardrail here. High beams, go ahead, BK. Boy, that is tough to see. If she was not wearing reflective material, it would be real hard. When you go back the next time, do like a sidewalk where you're facing directly towards me. Like a crab walk, so the reflective material that's on your side doesn't point towards me.
Yep.
Alright guys, that's going to be it for this video. My intent with this video was to arm you with enough information to where you could make the decision for yourself whether LED replacement bulbs are right for you. Thanks for watching this video. I hope you found it illuminating.